Hello and welcome to our review of lines and slopes for the benchmark. It's our second benchmark of the semester. And you typically might expect the first question in a review or a test to be the easiest. I think this review has the hardest question first. It asks a really general question that different students have a different answer to, and they're not wrong, but we're trying to pull it together and get the main idea here. And the question is, what is slope? Not what is the slope for a given equation or graph, but just in general, what is slope? And I looked online, I just typed in what is slope, and on this website, Basic Mathematics, I found a definition that says if you have ever walked up or down a hill, then you have already experienced a real-life example of slope. And here up north, we can say if you've ever skied, you know a little bit about it. As you go uphill, you may feel like you are spending lots of energy to get yourself to move. The steeper the hill, the harder it is for you to keep yourself moving up the hill. If you're skiing, of course, the harder it is to slow down. So our definition for slope is going to be the slope is the measure of the steepness of a line. And so if we think about a working definition, this definition is great, but it's not practical for some of the test questions you might have. So what I want you to think is, if you look at a graph, you find slope a certain way. If you look at points, either in data table form or just given 2 points, you'd find the slope in another way. And given an equation, you'd look at that information differently as well. So let's start with question 2 here. How can you determine slope using a graph? And in this case, what we typically do is find the rise, divide it by the run. So we might pick a point that we think of as what's called a lattice point and go up and over until we hit the graph. In this case, it was positive 1, 2, 3, 4 up, and 1, 2, 3, 4, positive 4 right. If we look a little closer, we see that up 1 over 1 would have gotten us onto the line. So rise over run, or rise divided by run, we get just by looking at the graph and counting vertically and horizontally. How can you determine the slope using 2 points on the line? Well, we would typically find and identify our coordinates as x's and y's and take the mathematical difference of the y coordinates divided by the difference in x's. So in this case, we could say the change in y coordinates divided by the change in x coordinates. And you'll typically not write it out. You'll just write the slope formula, m equals y2 minus y1 over x2 minus x1. Finally, and possibly the easiest, if we have an equation that we've identified as linear, and this equation form is called slope-intercept, we would simply look for the number in front of the x. Another way to say that is, if we're given a linear equation, and there are other types of equations, slope is the coefficient of x. All right, so we've got a general idea, the steepness, and also some working definitions. In real life, we see slope in any direction. However, in math, slope is defined from left to right. There are 4 types of slope you can encounter. A positive slope, a negative slope, and these are going to be the most frequent we find. But there are some kind of special cases, a slope of 0 or a slope that we call undefined. And I have a font here that's kind of hard to see, but undefined is kind of hard to visualize as well. If we follow a line from left to right, we can get a sense of whether it's positive, negative, 0, or undefined slope by noticing if from left to right your equation goes up, we would say it is a positive slope. And if from left to right you see the direction going down, we could say it has a negative slope. Likewise, if it doesn't go up or down, we would call that a slope of 0. And then finally, if it goes up and down from left to right, we would say it's undefined. It goes vertical. All right. Switching directions, when we talk about slope, we can compare the slopes of lines. And when we find that two lines have the same slope, we call them parallel. So what is true about slopes of parallel lines? The slopes are identical. We're not talking about the y-intercept here, just the slope. They will have different y-intercepts, otherwise it would be the same line. And what's true about slopes of perpendicular lines? The slopes of two lines that are perpendicular will be opposite reciprocals. And by opposite reciprocal, we mean if a fraction is given for a slope as, let's say, 2/3. Let's say the slope of one line is 2/3. If the second slope of a line, or the slope of a second line, is negative, that's the opposite. 3/2, that's a reciprocal. These two lines would have slopes that are perpendicular. How do you graph a linear function from an equation in slope-intercept form? Well, this is moving to the next level now that we understand how slope works and how points change from point to point. How do you graph them? Well, if you have slope-intercept form, you have something like y equals 2/5 x plus 1. And what we'd find here is our slope and our y-intercept, and we start at our y-intercept and either, what I say, move the slope, or students have said do the rise over run that you get from the slope. So in this case, we would put a dot at the y-intercept of 1, the value of y when x is 0. That x-coordinate, if that were a 0, we would plot the point 0, 1 here. And then the next point would be a rise of 2 and a run of 5. And we would put a dot there. Or we could do a rise of -2 and a run of -5. Put a dot there. Negative over negative is positive. And if we connected these dots, this is different than a scatter plot. We actually want to touch these dots. We would get the equation of a line, or sorry, the graph of a line passing through those points with a y-intercept of 1 and a slope of 2/5. How do you write an equation given a graph? Well, here, this is working the other direction. If I have this graph, I could simply identify my y-intercept and plug in the y-intercept and the slope. And it looks like my y-intercept in this case, right here, the value of y when x is 0, is 2. My slope is a rise of -2 and a run of +3. So, -2/3. My equation then is y equals -2/3 x plus 2. A good way to practice this is to take this equation that we get and try graphing it. See, we played a game like telephone where we had students go from one representation to the other as part of one of the chapters we did, and what you find is that people can interpret incorrectly. And so that was a good chance to see some of that. Finally, how do you write an equation given 2 points? And when we look at a situation like this, that last equation that we got had an y-intercept that landed right on the y-axis. In this case, we don't have that. And we don't want to estimate where that thing hits. So we're just going to take the 2 points, negative 1, 2, and the other point, 2, 0. And we'll find our slope. Two minus 0 divided by negative 1 minus 2. And what we get out of this is 2 minus 0 is 2, negative 1 minus 2 is negative 3, so we get a slope of negative 2/3. That's important. We don't know the y-intercept, so we can't plug into y equals mx plus b. We need to use point slope form, which is y minus y1 equals m parentheses x minus x1. So we plug in either point and we get y minus 2 equals negative 2/3 parentheses x minus negative 1 plus 1. Or equally correct is y minus 0 equals negative 2/3 x minus 2. We wouldn't have to put the y minus 0 in, noting that y minus 0 is just y. Okay.